In the last chapter, we dealt with quadratics. Those are polynomials where the biggest exponent on the x is a 2, an x squared. We're going to be branching out into larger equations, x to the thirds, x to the fourths, and so on. So if I had a big long polynomial, 4x squared minus 6x to the third plus 2x to the fifth minus, that's a plus, 4x to the fourth, we need to figure out what these graphs look like. Every single quadratic either looks like a smiley face or a frowny face, right? And we can figure out where that graph crosses the x-axis. We can graph them in vertex form. There's a lot we can do with quadratics. And because these are x squared graphs, that tells us that it could hit the x-axis twice. So following that logic, an x to the third equation could hit the x-axis 3 times. Now, does every quadratic hit the x-axis twice? No. They could hit twice, or they could hit once, or not at all. They could miss. Okay? So just because it's an x squared equation doesn't mean that it hits the x-axis twice. Okay? So looking at this polynomial, how many times could it hit the x-axis? We look for the biggest exponent. And the biggest exponent is a 5. And this number is called the degree. And usually, we write our polynomials in descending order. So we would start with the x to the fifth and then the x to the fourth, and we would go down in order. I just kind of wrote this one that way to confuse you. So the largest exponent is the degree, and that number is really important. This number is also really important. Does anybody know the name of all these numbers? They're called coefficients. So this is referred to as a term in a polynomial. So this polynomial, poly meaning many, nomial meaning number, many numbers, this polynomial has 4 terms. It has an x squared term, an x to the third term, x to the fifth, and an x to the fourth term. So there are 4 terms, and each of those terms has what we call a coefficient. I don't know where that word came from. That's just the number in front of the variables. So this coefficient has a special place in our polynomial, and it's called the leading coefficient. Even though it's not first. The number in front of the largest, the variable with the largest exponent is called the leading coefficient. And together, the leading coefficient and the degree give us the basic shape of the graph. Okay? So, let's look at an x to the third equation. How could we draw a graph that hits the x-axis 3 times? Well, one way to draw it would be to do this. Okay? And this is a positive leading coefficient. Okay? What would a negative leading coefficient look like? Well, it would start from the other direction. So that would be negative. And again, I could move it around and stretch it and pull it, but the basic idea is the negative leading coefficient starts up, comes down, and then down. Okay? What about an x to the fourth? Well, how would I draw a graph that hits the x-axis 4 times? It would have to look like a W. Is that a positive leading coefficient or a negative? It's positive, just like the parabola, right? A positive x squared has a smiley face. A negative x squared has a sad face. So this is a positive x to the fourth, and a negative x to the fourth would look like that. What? Oh, sorry. What about x to the fifth? What is it going to look like? Any idea? It's going to look a lot like Which one? It's going to look a lot like the x to the third, right? But as Tice is moving his hand up and down, it has one more wiggle, right? So a positive x to the fifth is going to go, this is the positive direction. It's going to go like this, like an x to the third, but it's going to have an extra wiggle in it. That would be a positive x to the fifth. And then a negative x to the fifth would look like this. And again, I can stretch and pull and twist and change the shape of it, but the basic idea is the same. Now, can we guarantee that every x to the fifth hits the graph 5 times? No. In fact, it might only hit once. That is still an x to the fifth. And an x to the fifth can actually look a lot like an x to the third. So it could look like this, which is strange. Okay, what about x to the sixth? What is it going to look like? It's going to be a triple U, right? Like that. Or, what would it be? A triple N? A 1.5 M? So an M with an extra M and triple N. Does that make sense? So, if I said, what is a negative x to the 17th going to look like? Well, all I really care about are the endpoints. So, in the middle, we're going to have a lot of this, right? But what does the left side look like, and what does the right side look like? Well, this is going to be similar to what? Is it going to look like a parabola? No, why not? Well, the 17 tells us, are the two ends going to go in the same direction, or are they going to go in opposite directions? Opposite, why? Odd number. On an odd number, right, we do the disco dance. It's either, this is a positive, this is a negative. That's my only dance move. So it's either going to be up to the left and down to the right, or up to the right and down to the left. Which one is it? It's this one. So if I were to draw this, I know that the left side is going up, and then a whole bunch of wiggles are going to happen in the middle somewhere, but the right side is going to go down. And we can figure that out just by looking at the degree and the leading coefficient, the sign of the leading coefficient. So odds have one up and one down, and evens are either up, up, or down, down. Does that make sense? Okay. If you understand that, today is going to be quite easy. So here, what is the degree and the leading coefficient? The degree is 4, that is the largest exponent, and the leading coefficient? Positive 1, or just 1. Okay, let's look at another example. Degree, 4. Leading coefficient, -3. So what is the basic shape of this going to be? It's going to be an M, right? It's even, so the ends have to go in the same direction, and it's negative, so this basic graph is going to be something like that. Now, it might miss the x-axis entirely, or it might hit the x-axis once, or maybe it hits the x-axis twice like that. We don't know. But I do know what the endpoints look like. Okay, seems like everybody understood that. Let's skip to this one. Okay, letter A. what are the ends going to look like? Well, what is the degree? 5, which is odd, which means they're opposite. And the leading coefficient is a 6. And the number 6 doesn't really matter, but the fact that it's positive 6 is important. So what would a 5th degree polynomial with a positive leading coefficient look like? So it's going to be down to the left and up to the right. So rises, falls to the left, and rises to the right. That's the one. Does everybody understand that? So remember, if it's even, that's plus. And if it's negative, it looks like this. And for the odds, this is plus, and this is minus. Okay? All right. So the next one, we have a positive x to the 4th. So what will my endpoints look like? They're both going to be up. Rises to the left and rises to the right. Does everybody understand that? Karen, you good? Okay. All right. Now this last one's a little bit tricky. What is the degree? It's not 2 because it's all multiplied together, right? So this is going to be some long equation, right? All I care about, though, is this term here. What creates that term? Well, it's this times that, right? Now, there's lots of other stuff in there, but I don't care about any of that other stuff. So what is negative 5x squared times 3x times x? Well, that's going to be negative 15x to the 4th. So what does a negative x to the 4th look like as far as end behavior? It's an m. So falls to the left and falls to the right. Okay, let's do another one. What if I had negative 6x squared times x plus 2 to the 3rd times negative 3 minus 2? Okay, now we have to be careful. Negative 6x squared times what? It's, oh good, x cubed. Do you guys see that? This is x to the 3rd. And again, there's a lot of other stuff in there, but all of that is not going to be in the degree or the leading coefficient. And then a negative 3x. So that gives me 18x2 plus 3 is 5 plus 1 is 6. 18x to the 6. What does the end behavior look like? It's a smiley face. Left side up, right side up. I did that backwards. Okay. Does that make sense? Okay. That's the first half of today. The second half is finding the roots. So here we have a binomial, which means a polynomial with 2 terms, times a trinomial, which is a polynomial of 3 terms. And what are the roots? So this is a v to the 3rd equation. Do you see the 4v times the v squared? But this wants to know what are the roots. Well, we just set each of these equal to 0. And this one's easy. I add 16 and divide by 4, and I get v equals 4. And this one I plug into the box. So we plug in v squared and 21. Multiply those together. 21v squared. Are there factors of 21 that add to be 10? 3 and 7. So 3v and 7v. What do these share? of v. When I pull out a v, what's left? V plus 3. And I pull a v out of this, what's left? V plus 7. And then it's always a good idea to check, is 7 times 3 equal to 21? Yes. So my other roots are going to be based off of v plus 3 equals 0 and v plus 7 equals 0. So this is v equals negative 3, and this is v equals negative 7. So my three roots are 4, negative 3, and negative 7. Did I lose you? Oh, that's okay. We can do another one. All right. So let's stick this in the box. Y squared, negative 12. Multiply those together. Negative 12y squared. Are there factors of negative 12 that add to be negative 1? That would be negative 4y and 3y. Everybody all right? Okay. What does the top row share? A y. And that turns into y minus 4. And then pull a y out of the first column, and I get y plus 3. And then double check, is 3 times negative 4 equal to negative 12? Yeah. So my roots are based off of y minus 4 equals 0, y plus 3 equals 0, and then this one, 3y minus 27 equals 0. So we add 4 here, and I get y is 4. What's the root there? Subtract the 3, negative 3, and what about this root? We're going to add 27, and then divide by 3, and the answer is 9. Good job. Okay, those are the three roots. So what would this graph look like? Well, it has to hit at negative 3, and again at 4, and again at 9. So that is the graph. Okay. Okay. So here we have a piece of a polynomial, weird looking polynomial, and it wants to know, is f of 5 positive? So this is my x-axis, and this is my f of x-axis, also known as y. So f of 5 means what happens when we plug in 5? So if I go to 5 on my x-axis, I get the answer of negative 2. Is f of 5 positive? No. Okay. For which values of x? Oh. No, we don't want to do this question. Nope, I'm going to toss up. Okay. Which means that's it for today. Okay, I'm going to throw that question out. I didn't like it.